universe, a gamma-ray burst. In a small percentage of these massive Death Stars, a gamma-ray burst is triggered by the crushing transformation of a dying star into a black hole.
As a star collapses, it produces a massive electric field, and in an instant, the energy from this electric field is turned into matter and antimatter particles, which then collide with each other and produce a huge pulse of energy.
They are the most powerful energy beams in the electromagnetic spectrum, more lethal than microwaves, infrared energy, and even X-rays. Humans have learned to harness deadly gamma rays for useful purposes, such as food irradiation. By using gamma rays, food processors can eliminate microorganisms, bacteria, viruses, and insects. But the amount of gamma radiation applied is an extremely tiny fraction of the energy released in a stellar gamma-ray burst.
Gamma-ray bursts produce so much radiation that if we were to create a gamma-ray burst on Earth, it would be like a huge number of nuclear bombs going off. It would be devastating for life on Earth.
For the human race, the most critical piece of information about gamma-ray bursts is the direction of fire. At the moment of collapse, the star becomes a dense, flattened disk, and the rotational axis poles are its only openings free of dense star matter.
You get two relatively evacuated regions along the poles, and it's along those directions that material can be ejected because it encounters relatively little resistance. So this container of yogurt provides a nice analogy for what happens in a gamma-ray burst. I'm going to drop the container of yogurt, and because of the sides of the container, yogurt is not going to be able to go out along those directions. But the top of the container is open, so yogurt is going to squirt out along the top. Watch what happens. So the yogurt went squirting basically straight up. It couldn't go out the sides because it was blocked by the sides of the yogurt container. And that's a nice analogy for what happens in a gamma-ray burst.
The greatest concern for humans is the direction that the gamma-ray burst is firing. If the axis of the collapsing star is pointing in our direction, we could be in serious trouble. When Peter Tuthill's team studied the plane of orbit of WR-104's dust plume, they came to a shocking realization.
This spiral was the key that unlocked a lot of these secrets. And where things start to get a little scary is that this system, at first blush, appears to be almost face-on. We're looking right down the axis at the heart. It's like looking at a plate, a dinner plate. If you take that plane and you tilt it to the line of sight, it looks inclined. You're no longer looking at a circular dinner plate.
Further examination suggests the rotational axis of the dust plume appears to match the rotational axis of the Wolf-Rayet star itself, meaning the Earth is staring directly down the barrel of a gun.
That means that if this star becomes a gamma-ray burst when it blows up, one of the two jets will be pointing toward us.
The beautiful spiral of Wolf-Rayet 104 is suddenly a messenger of doom. Some 8,000 light years from Earth, two stars are locked in a gravitational dance. Their stellar winds ejecting a vast cloud of dust in a graceful spiral. But there's more to this star couple than just a beautiful tale. The larger of the two, Wolf-Rayet 104, is a massive Death Star on the verge of exploding as a supernova. That much is certain. The real mystery is, will it also unleash a gamma ray burst, or GRB, the most powerful burst of energy in the universe? The question is an important one for all on Earth, especially considering the star's axis may be pointing directly at us.
That means that when it blows up, if it becomes a gamma ray burst, the jet could be pointing straight at us.
WR-104 is counting down to destruction in the constellation Sagittarius. Named by Roman astrologers over 2,000 years ago, Sagittarius is Latin for the archer.
And you have to ask, maybe were the ancients onto something? Is there something to do with the archer aiming at us?
WR-104 can be thought of as an arrow pointing our way, if indeed it blows up as a gamma ray burst.
There is little dispute among today's astronomers that a tightly focused beam from a gamma ray burst will travel vast distances in space. In fact, on April 23, 2009, the Swift Multi-Wavelength Observatory, orbiting the Earth, recorded a GRB that occurred 13 billion light-years away from Earth, near the very edge of the visible universe. The blast occurred only about 630 million years after the Big Bang. This means that gamma rays from the exploding star traveled at the speed of light for 13 billion years before they were visible to us, making this gamma ray burst the oldest stellar object in the known universe.
We know of no star or galaxy that's farther away than this gamma ray burst. It's the single most distant discrete object ever seen.
At only 8,000 light-years, a GRB blast from Wolf-Rayet 104 could be catastrophic.
The flash that we would see if Wolf-Rayet 104 went off would be much brighter than the sun, especially at gamma ray energies. A single gamma ray burst can easily exceed the total light output of millions of galaxies. And each of those galaxies contains 100 billion stars.
This Death Star is a ticking time bomb. Scientists know for sure it will go supernova. But questions remain about its potential to unleash a gamma ray burst in the direction of Earth.
That's the first point we need to establish. If it does produce a gamma ray burst, is that gamma ray burst pointing towards us?
The spiraling axis of the star appears to be aimed in the direction of Earth. But with thousands of light years to travel, would the GRB beam actually hit the target? Would the archer's aim be true?
We know it's pointing roughly toward us, but it could be pointing sufficiently away that the beam of radiation from the gamma ray burst, if it turns into a gamma ray burst, will actually miss us.
However, if the star is aligned, one powerful burst